I'm actually going to skip SSH and SMB for now, and I'm going to go over to SMTP. SMTP stands for Simple Mail Transfer Protocol, and it's used to send emails. There are many attacks associated with SMTP that I will not be talking about here, such as SMTP Open Relay. An open relay allows anyone to relay email messages through an SMTP server, potentially modifying the from address and pretending they are somebody who they really aren't. However, all of these sorts of attacks actually target the recipient of the email, and so they're targeting people and therefore can be seen as social engineering attacks. For this reason, I won't be covering them here because they aren't relevant to the NCE Cyber Games competition. However, I wanted to mention the existence of these sorts of attacks just for the sake of completeness. There are, in addition to these, some attacks that do target the service itself and that an attacker could abuse to gain access to that server. And these are the ones I'll be talking about in this video. First of all, just like with all these other services, one of the primary ways an attacker can get in is through an outdated service with a known vulnerability. I'm not going to be showing this again because I already covered this when we were talking about FTP. So we're going to move on to the other ones. Back on my attacking machine, I'll be attacking the same target 10.0.0.11 where I have SMTP running on port 25. If I scan that port with Nmap, I'll do the same scan I did before where I'm scanning port 25, grabbing the version of that service, running the default Nmap scripts. Then I have to specify my target. And you'll notice that it tells me that port 25 is open, it's running SMTP, and the version, it doesn't have a full version number, but it knows that it's postfix SMTPD. It also gives me some additional information, such as which SMTP commands are actually permitted by the SMTP server. Since this is the unencrypted version of SMTP, there is an encrypted version on port 587, but right now I'm working with the unencrypted version. I can directly connect to it with a raw netcat connection, similarly to how we did with FTP. So if you remember, we used NC for netcat, then the target, which in this case is 10.0.0.11, and the port I want to connect on, which is 25. Now that I've connected to this mail server, what can I do with it? Well, first of all, if you're familiar with how the SMTP protocol works, the first thing you need to do is announce yourself by saying hello and then the name of, or the domain name of the user. So if I say hello, and I can just put any name I want, in this case I'll just put an X, that introduces me to the SMTP server. And from here, I have a bunch of options of different commands that I can run. One of those commands that's particularly interesting is the VRFY, or verify command. This command allows us to verify if a user is present. The purpose of this is to be able to verify if I can actually send email to a specific recipient. So if I verify user root to see if root is present, you'll notice that it returns with a 252 and it says root. This indicates that the user is present. If I try that with a bogus user that doesn't actually exist, for example, I can try user bogus, you'll notice it gives me a different response, 550, and it says the recipient address was rejected. I'm going to quit to exit the SMTP connection. Knowing this, knowing that we can test if usernames are valid or not, we could actually write a script that goes through a bunch of common usernames in Linux and tests all of them out to see which usernames are valid on our target. And while this may not be useful on its own, when you combine this with some of the password attacks that we'll look at later, knowing the usernames for users that are present on the target can actually be pretty useful as an attacker. Instead of writing our own script, there are actually built-in tools in Kali Linux that let us do this, one of which is SMTP user enum. So if I say SMTP user enum, and I can add the -h flag to display the help screen, it gives us some examples, and we can basically follow these examples. It looks like what we need is -m for the method. We'll talk about other methods later, but for now, we'll use the VRFY method. Then the next thing we're going to do is we can use lowercase u to specify a single username to check if it's valid, for example, root. And then we use -t to specify the target, in this case, 10.0.0.11. And you'll see that here we get that root exists, but if we were to once again enter bogus like we did before, it doesn't tell us that bogus exists. This may not be useful if you have to test every single username one by one, but you can also pass in a list of common usernames in Linux. Since I don't have a very good list of common usernames already on my Kali machine, I'm actually going to install seclists, which is a package for Kali that has a lot of common word lists that you can use for various things. Among them, it contains a user list for common usernames in Linux. To do that, I'm going to say sudo apt install seclists. I'm skipping a little bit ahead in the video here because you'll notice that the first time I tried running that, it told me that the package does not exist or unable to locate package. That's actually because my apt repository cache was not updated. So I ran a quick sudo apt update to update that cache. And then from there, when I tried the second time to run sudo apt install seclists, now it installed without an issue. I can actually access these word lists by going to changing directory to user share seclists. And if I listed the directories in here, you see we have a lot of different directories containing word lists for various things. So I'm going to head over to that usernames directory, and I'm going to see what kinds of usernames we have. So we have a short list that just has some of the common usernames, and then we have these much longer ones, like the 10 million usernames lists here. If I just print out that top usernames short list, you see we have some of the most common usernames in Linux. And so I'm going to be using that list in this example. But as an attacker, if you had more time on your hands, you of course could use one of these larger lists. It would just take longer to run. So using this list, I'm going to say SMTP. I'm actually going to take this command that I used before, and I'm going to modify it. Instead of a lowercase u this time, I have to use a capital U because I'm specifying a word list. And I'm going to use the word list top usernames short list. And now if I run that, this time it tried all the usernames in that list and it returned the ones that are valid, which includes root, like we saw before, but some new ones like MySQL, user, and FTP. Now that we know this, we can actually create a word list for future use that's going to contain usernames that we know are valid. So I'm going to go back to my home directory, and then I'm just going to create a new file here that's going to contain usernames. I'm going to go ahead and copy this over really quick. And I'm going to just edit this so I have each of the usernames on a separate line. You'll see why I'm formatting it this way later, because we're actually going to be using some tools where we can pass in a list of usernames. And those tools expect each of the usernames to be on separate lines. Once I've got my usernames in here, I can say Control-O to write that out and Control-X to exit. Going back to being a defender, let's take a look at the traffic that generated in Wireshark. I'm going to skip over the beginning because this is all related to that Nmap scan that we did. As you can see, the Nmap scan first checked to make sure that port was open, and then when it identified the service to be SMTP, it ran a few additional checks by connecting over SMTP. However, we're going to skip closer to the end and see our SMTP traffic here. If I right-click, follow, TCP stream, you can see that that tool, SMTP user enum that we used, it connected to our SMTP server, it introduced itself, and then it just used verify to check each user in that list. It repeated this process for every user that was in the list. So in this case, it's verifying user EC2-user, and because that user did not exist, we got back a message, recipient address rejected. I'm going to clear out this filter for now, and similarly to what we did with FTP, we can actually check for an attacker using this verify command. So if I go to edit, find packet, again, I'm going to search the packet bytes. I'm going to search for a string. This time I'm going to search for VRFY. The other thing I'm going to do just to narrow down the traffic first a little bit is I'm going to restrict it to SMTP traffic by typing in SMTP, pressing enter. Then when I actually look for VRFY, this actually may not be the best search string to choose. And here's why. If I right click on this, follow TCP stream, you'll notice that whenever anyone logs into our SMTP server, it's always going to return and say, hey, verify or VRFY is one of the available commands. So if we just search for VRFY, we'll get a lot of false positives. Instead, it may be more useful to search for a rejection message. So you'll notice when an attacker tried to verify a user that didn't exist, it returned recipient address rejected. So we can actually just search for the word rejected. Searching for that, now if I right-click on this, follow TCP stream, now we actually see an attacker, which in this case was us, verifying to see if root and bogus exist. You can also get a little bit more creative with your searching. So let's take a closer look at that VRFY being printed out by the server. So here we'll notice that VRFY actually ends with a new line character, and the next thing that's printed is that 250. However, if we look at VRFY being used by an attacker, you'll notice that after that VRFY, there's a space before the attacker types out the username that they want to verify. So what we can actually do is we can refine our search. So I'll again filter by SMTP. And this time, instead of searching for verify by itself, I'll put a space at the end of it. And now, if I try to search that, you'll notice we only get all of the instances where the attacker actually used the command verify. Going to the actual victim machine itself, let's check the log files to see more evidence of the attack. To actually determine where the log file is for postfix, which is the SMTP service I'm using, I can run sudo postconf mail.log _file. This will actually give me the full path to that log file, which in this case is var log mail.log. So if I print out var log mail.log, you'll see that all of the actions that we took as an attacker are logged in here. In fact, it even mentions, as you can see, this VRFY, if you look closely here, my cursor is not showing, but hopefully you can see that. It says 0 out of 1, which indicates that the person who logged in used the VRFY command. They tried one username, and that username was unsuccessfully verified. If you were searching specifically for an attacker's use of verify, you could grep for verify. So grep -n to get the line numbers, VRFY, which is what we're searching for, and then var log mail.log, which is our log file. Running this, you can see, for example, verify was tried on lines 111, 114, 116. So again, I can say sudo nano plus 114, for example, and then the log file, var log mail.log, and that takes me right to that line where the user used the verify command. Now the question you might be asking yourself is, can we actually see the usernames that the attacker tried? So if we look at this log here, it looks like we actually get this rejected message here, and it tells us that the username that was attempted was Azure user. So we can actually view the usernames that the attacker attempted that didn't actually exist on our machine. However, the problem is it doesn't actually print out messages for when a user was found. It only shows us messages for when a user was not found. So this is where actually looking at the traffic logs in Wireshark may make more sense, because then you can fully see which usernames the attacker was able to successfully verify, as opposed to which usernames got rejected. How can we stop attackers from actually being able to use this VRFY command to verify whether or not users exist on our server? Well, there is actually a configuration option in Postfix that allows us to disable the verify command. To configure options in Postfix, you can use the postconf tool. So if I say sudo postconf, and then I list this option, disable VRFY command, running that, you can see that disable VRFY command is currently set to no, which means that attackers or anyone that connects to our SMTP server will be able to use the VRFY command. If I wanted to change that to yes, so that that command is in fact disabled, I can take that same command that I previously ran and just add an equals yes to the end of it. Once that's done, now if I were to look at that configuration option again, you'll notice that this time it's set to yes. Since I changed the configuration, I'm also going to reload the postfix service. So I'll use system control, so sudo system control restart postfix. And I can make sure that it restarted successfully with system control status postfix. Going back to my attacking machine, I can check whether I can still use the VRFY command. So I'm going to check it by performing the same steps that I did before. If I use netcat and connect on port 25 to my target, I'm going to say hello and then my domain name, which in this case is just going to be an X. You'll notice right away that VRFY is not listed as one of the options for valid commands that I can use here. If I try to say VRFY root this time, it says that the VRFY command is disabled. Now that we disabled the VRFY command, does this mean that an attacker is out of options, that they can no longer list usernames? Well, actually the answer is no. And to understand why, we have to understand something else about how the mail server or SMTP works. In SMTP, when you specify a recipient, the mail server will actually tell you when that recipient is invalid. This is very useful in case you try to send an email to a recipient that doesn't exist. Then the mail server will alert you that the recipient doesn't exist and therefore cannot send your email. However, as attackers, we can abuse that functionality similar to how we did with Verify in order to see if users actually exist or not. The only difference is, instead of using the VRFY command like we used before, we're going to use the RCPT TO command to set the recipient of the email. And we'll see if the mail server tells us that that recipient is invalid. Rather than showing this manually like I did with the VRFY command, instead I'm just going to right away use that SMTP user enum script and try it against this username list. If I take that command that I ran before, the SMTP user enum command, the only thing I need to change is the method, and I'm going to change it from VRFY to RCPT. When I run that, you can see that despite the fact that I disabled the VRFY command, we're still able to check whether these users exist. In this case, we get root, user, MySQL, and FTP. As defenders, just like with the VRFY method, we can find evidence of this in the logs by searching, for example, for the word rejected, which will show all of the packets that contain recipient address rejected, or where an attacker tried to send an email to a recipient that doesn't exist, and they got back the message that that recipient doesn't exist. Looking at the log files, once again, we can see that in the logs. We can see that user unknown in local recipient table, and it gives us the from email and also the recipient that the attacker attempted. So just like with VRFY, we can see this the same way both in our Wireshark traffic and in our mail logs. How do we actually fix this as defenders? Well, that's kind of a trick question because we can't. This is fundamentally how SMTP works. And so this is an example of one of those instances where an attacker actually abuses intended functionality. So our best bet is to monitor our logs and monitor our network traffic and find evidence of attackers trying this against us. Remember that an attacker knowing what users exist on our machine doesn't necessarily give them a way into our machine. It just gives them further information that they can later make use of in conjunction with other attacks. Going back to our attack vectors list, looking at SMTP, we already covered this VRFY, EXPN, or RCPT TO user disclosure. And we've already covered outdated service when we were talking about FTP. Again, plain text login and data transfers just means that everything that you could see as a defender monitoring the traffic, an attacker could see that too. And so if they are monitoring traffic and somebody else perhaps logs into SMTP, an attacker could see that and gain potential username and passwords, or also just read the emails that are being sent over. And then the last thing, insecure passwords. Again, if you're using authentication to talk to SMTP and you're using an insecure password, an attacker could potentially guess that password. We're going to talk about password attacks right now as we switch over to taking a look at SSH.